My name is Ramon.
That takes things. I heard it watching it last.
I've watched it at least a dozen times. He made
I
it.
haven't watched it at all.
He made
Are
it.
you kidding? It was great.
I'm Ray Crosby-Willis. You two know me. I don't know you guys. What's your name? What is it? Andrew, Lisa, Sarah. What are your names?
Jennifer?
Adrian?
Avery.
Avery. Nice to meet you. AJ? All right. So I'll just tell you a quick couple minutes about myself. I won't bore you with it, but I've been interested in mainly theater since I was in elementary. I had a strong influence because I was relatively close to the drama director of Lennon Central School, having to be my mother. So I hung around the stage a lot, and therefore, gained interest more so towards the technology side of things, behind the scenes, rather than on stage. Even though I did try on stage when I was in elementary, but decided it wasn't for me until the video. Anyway, so I've been probably doing audio probably close to probably 20-some years. I've been doing theater and stage work professionally for about 18 years, and I've been a member of the Theatrical and Stage Employee Union for about 12 years. And I primarily work on the stage in Elmira, the Clemens Center, a lot of the lighting and audio work for them down there. So the show comes in, we help load them in, connect all their parts and cables, towers, like towers, sound towers. And then at the end of the show, we load them back out onto their trucks and away they go. That's primarily what that involves. I do get to work some of the shows, which is fun because you see part of the show, whether you're backstage or running the follow spot. Anyway, so I won't bore you anymore with that. I did graduate from the Institute of Audio Research in New York City in 2005. I got a degree to professionally record live musicians and bands. It was hard because my main focus was live sound, live theater, and they didn't really focus on those details. But I was able to take from there and use that in the field that I like to do. You might wonder, what do I do now? Well, I don't do this like 75% of the other people in this county. They don't do what they learned or what they're taught or went to school for. So with Pitco and the schools, it allows me to keep doing this, and so it's more or less a hobby at this point, but I really enjoy doing it. So with that said, we'll continue with what we're here to do, and it was advertised as sound design. However, I'm going to give you guys the choice whether you want to look at the design of sound and how sounds are perceived and how they're used, more so like in a recording studio, just because that's kind of how we're set up here. Or we can do more the side of things of the introduction for audio. So learning about what the different things are and learning about how it plays a part in theater and stuff like that. So does anybody have a preference one way or another? I'm kind of prepared to go both ways. We can maybe kind of mix a little bit of the two also.
I don't think we know anything.
Don't know.
So whatever you want to teach us, that.
So I think I'll stay more so for the introduction of things, just so you can see things. So I do have a slideshow kind of put together. It's the same slideshow I actually used this summer for the kids' youth camp. And I'll just go through it, and then we can kind of talk about things. I do have obviously some things here that you'll see on the screen. Yeah, Lisa, if you want to come around so you can see.
I can see. Yeah, thank you. Yeah.
Okay.
Keep my 6 feet. I can see. No, thank you.
All right, I'm not a PowerPoint person. What makes it go to the next slide, Dustin?
The camera.
Nah, thank you.
Oh, we were all day. Need help here?
Yeah. There we go. Okay, so we're talking about audio systems. They're kind of different between the audio, live audio and recording, just because of what you need for different places. Is relatively the same, but you're going to see some differences. So what you're going to see in both settings is some kind of mixer. So this would be a soundboard or an audio console. Some people call it the audio desk. You're going to have some outboard gear my computer running sounds into the board or a phone. And then it consists of amplifiers and speakers. So these are basically all the components you're going to need to run a full audio system. Two types of mixers, analog and digital, which we'll get into a little bit more, but this is actually, when you see the picture there, this is a full digital board. Allows you to do basically the same things on an analog board, but the versatility of it is very broad and allows you to do quite a bit more. But the same functions overall are the same. Okay, now it's not working out. Look at this screen, it doesn't show. Okay, here's some different sizes and styles. So that would be a small, I guess a 3 or 4 channel. There's another digital one, it's 32. It's very similar to this one, which is a different manufacturer. There's this one. That would be what you'd see on a big show, kind of like a big rock concert or something like that. And this is one you would typically see in a recording studio. So you can see the similarities, but they all function just slightly different. I had this picture stuck in there. This was our audio setup for the haunted house last year, not this year. Outboard gear. So outboard gear, you can kind of think of as a box that's not part of the console that you would see typically in a rack. So touring shows or stage shows, they would have it in a case where you could roll around and have wheels on it. Or in a recording studio, you would see it built into like the wall or under the desk or something because they just stay there all the time. But they would consist of microphone preamps, compressors, gates, expanders, compression, sorry. And again, we'll talk about some of that stuff. So there's like a guy in his home studio, and you can see some of those boxes above his keyboard there. And those would be the outboard gear. And we'll talk again about what they do. There's a little bit bigger studio, okay? And there is a really big professional studio. So they just have walls of these outboard gear. Because every musician comes in, they want their own sound. They know what they want, or the producer says, no, this needs to sound like this or that. So that's what these are going to be. So that whole wall right there will all fit inside this digital board. That's the difference between analog and digital. Now, the one big difference is some of those preamps I was telling you about. The preamps are what power the microphone. They used to use tubes, and the tubes give a nice, rich, warm sound. And probably like this one here, there's probably going to be a tube preamp. But they still make tube preamps because, again, people like those sounds. So what you do in the digital world, they try to emulate it. So they try to make it sound like that, which, the way things are nowadays is very, very close. But still people are like, no, I don't want that. I want that sound, So people can be very picky on what they want their instrument or voice to sound. Different microphones. We have a handheld microphone, a lavalier microphone, which is right here. And, I'm just going through this stuff real quick because we're actually going to come up here and look at all this stuff. Wired, wireless, instrument microphones, and then your computers or other inputs. So this is a handheld microphone. That would be a handheld wireless microphone. That's a wireless lavalier like we have here. That is an instrument mic. It has a little clip on it, so you can clip it onto like a trumpet or a saxophone. They have some for flutes, or basically any type of instruments. That is a recording microphone, so you can see that in the studio. And does anybody know what that brown thing that says Rode on it? You got to speak up. Yeah, that's exactly what it is. It's a pop filter, so it gets rid of that. Here, I can take that for you. Hey. So you don't want that in your recording. It's very annoying. It doesn't make you sound very nice. So that's what that does. So there would be an instrument, but you can see that guitar is plugged into. So this top box right here is the amplifier, and this lower box is the speaker. So usually electric guitars, you'll see they have foot pedals. Now foot pedals do what? Anybody know? You've seen it, right? Right, you see them always stepping on something different, right? So they make that guitar sound different. So they're like distortion and reverb. They give it that unique sound. Because the electric guitar by itself just sounds like a guitar, only electric. It doesn't have all those extra sounds in it. So that's what all the foot pedals do. So you can see all the foot pedals before the guitar actually gets hooked into that. Yeah, just regular string, right. Then there is a microphone picking up an acoustic guitar. They also make pickups for electric guitars that fit right inside the sound box. Or sometimes there's a pickup on it like electric guitar, very similar. But a microphone is going to get more of those sounds, whereas a pickup isn't. We probably won't get into that too much, but just know that you can record or pick up a electric guitar a couple different ways. But a microphone is going to be a very nice, true sound. And this would be like your other input, so that it shows the computer hooked up to it. And that's a keyboard, so just like another source. And then this box right here in the middle, I did not bring one with me. It's called a direct box, and it basically takes the audio signal from your keyboard or your laptop or computer, and converts it into a balanced signal. So if you don't have a balanced signal going through your wire, it could pick up a lot of extra things that you don't want. So if you run your cables next to power cables, like we have plugged in the wall, you're going to pick up a lot of electromagnetic sounds, and they're going to affect that sound. So we convert it to a balanced signal to stretch that sound farther and not pick up those sounds. Exactly. We don't want weird noises in our sound. Right? And I don't think I have any way to show you that, but I'll look. Okay, so we're just talking about wireless microphones here. So that is a two handhelds on one receiver. This would be a lavalier and one receiver, and that's all we have here. One lavalier, one receiver. So that's just one channel. You might see this like over at the school or something where we have, there's 4 units there, but they could be dual receivers, so there might be eight wireless mics there. Then if you go to a big, theater production, you're going to see a few racks full of them. They're running like 60 wireless microphones. Some actors and actresses will wear 2, sometimes 3 wireless microphones. More so for backup, and also sometimes the actor wears a hat. You put the hat on, you cover the microphones. The microphones are always attached to the head. As soon as you put a hat on, so they actually put one inside the hat. And so when the actor puts the hat on, then the audio engineer switches over to the hat mic. Does that make sense? So that's sometimes why you see so many wireless microphones, because you just don't want to lose a signal, and the reasons for the hat or something. Here's a couple of connectivity. They show a couple microphones in this one. They're just really small mixers, something I can already show you. Amplifier. So we have our microphones or our other inputs going into the board. Now we need to take it somewhere else. And we're going to send it to our amplifiers, because our amplifiers are what power our speakers. Here's a small rack of amplifiers. Now every amplifier usually has 2 channels, so you can run 2 separate speakers, usually a left and a right for stereo. So there are 4, so you have 8 channels there. And then again, if you go to a big rock concert, lots of speakers, lots of amplifiers. Okay? Speakers, they have passive and active. So the passive, there's no built-in amplifier, so you can see that wall of amps or the rack of amps. Or the active ones are like this guy here, it has them built into it. So all I have to do is take my source, my signal, out from the board directly to the speaker. And here's more of a monitor style. This is not really for projecting sound to over a crowd or audience. But for this case, it works perfectly. So there's a couple pictures of passive. The ones on the stands are kind of what we would use for small shows around here. And then if you go to a big arena, you would see something like that. They call that a line array. I won't get into this because I'm going to basically show you up here. quite a few knobs in line with each slider. See the sliders here? And then if you get down here to the digital board, you have the slider, and then you have 1, 2, 3 buttons, and that's it. There's no knobs above each channel. So we'll get into that once we get up here as well. There's just another look at the analog board. So your microphone or other input would get plugged in up here, and then all these knobs affect that sound, and then your slider gets to choose how much output, how loud it is. And again, I know I'm sorry I'm rushing through this, but I really want to get to the hands-on stuff because that's where you're really going to see this stuff in action. There's this board, what you're going to see when you come up here. Okay, that's it for the slideshow. So, I forgot my water. Can I drink this hand sanitizer or whatever?
I mean, would kill you. Oh,
So I'll just show you a little bit from here before we get up close. That way, I don't have to wear the mask as much. This is a wired handheld mic. So a lot of singers or actors, not actors, sorry, mainly singers or performers on stage would use this. The actors that would use the wireless mic, the lavalier specifically, because you can hide it. Or if you're doing a TV interview or something like that, they call this a lapel because you can put on your lapel. Let's see if I have it. 1, 2. There we are. Check 1, 2. So you hear that ringing? It's because I'm standing in front of the speakers, and we call that a feedback loop. So basically, the microphone is picking up my sound that's coming out of the speakers, and it's making its loop. And those specific frequencies are what's making that ringing. That's no different. If I keep turning it up, it's gonna be very loud and very obnoxious. So we won't do that. That's exactly what this will do. So that's why. Yeah, go ahead.
Since that is wireless, how does the board know that slider goes to that?
So this is a receiver. So the belt pack would be your transmitter, and it transmits the audio through the airwaves onto this receiver. Those little antennas pick up that signal. And then on the back, I use a microphone cable. So now basically this is my microphone. You see my mic cable here? And there it is coming out of the receiver. And then I have it plugged in to a specific channel on this board. And then from here I can select how loud and how I want that to sound. Does that answer your question?
You have one of those, like if you had 10 of those lavalier,
Yep.
you could have one
And I'll go back to the slider real quick.
You could have 10 receivers.
what
some
Pico
receivers-
owns, you need your own.
Some receivers can run 2, pick up 2, and some just pick up 1. But that's that thing of receivers that we showed you on the thing. If there was a show, they have a whole bunch of receivers, and that's why. And each mic has its own number. So one of the things they do before the show, when they set up the mics, is they leave those 2 in that lavalier, that particular number with that receiver to make sure that those 2 are fine. When you see some guests running around, a lot of times that's because something's not leading together correctly.
And he moves faster than Grace.
Ray
And Simon moves faster than Grace.
Ray stays at the board and he
So-
runs and does stuff.
So this particular receiver will pick up both of those microphones, whereas that receiver is only good for that one microphone. Does that make sense? And then that's why you see all these. So every row is good for 2 mics. So every green screen you see there. So the screens are so you can dial in the frequencies that they react on, because sometimes you get frequencies too close, they're going to overlap each other and then basically create a lot of nonsense that you don't want. So program each frequency. They all have to have their separate frequencies so they're not overwriting each other. That between what she said, answer everything?
Yeah. So it's almost like back in the CD radio camera, right, as the channel.
Yep.
Exactly.
It's no different than your radio in your car. When you switch to a different frequency, you hear something different.
And in fact, they just changed the requirements on what the theater could use, what ranges they could use. And so a lot of the old receivers receivers that we have don't work anymore because we're not allowed.
They're basically illegal.
Yeah.
Because
we're
somebody
not allowed.
bought a chunk of frequencies and said you can't use our frequencies. Long story short, that's basically what happened.
Yeah. So we're not allowed to use not with those frequencies.
You got to speak up.
For example, if you mess around with frequencies or walkie-talkie and you heard a bunch of truckers talking, it's just like private information.
Right, they're either on the same frequency or a frequency very close, and then that's why you're able to hear them. Okay, where did we leave off? We answered everything for you? Okay, anybody else have any questions this far?
When you mentioned that your speakers are set up left and right, is that house left and right because the sound person is out in the house, or is it stage left?
Typically, after you cross into the house, so after you're off the stage, and you're talking about left and right, you always refer to it as house left and right. So as you're, say this is the stage, this would now be your left and this would be your right. But when you say stage right and left, that's when you're on stage. So I'd be on the stage now, and this would be right, and this is left. So it just depends on where you're standing and what you're referring to. So yes, these would be our main speakers for our house, so this would be house left and this would be house right. Does that answer you? So we were talking about microphones. Where do I want to go with that?
You've gotten through slides. I think you brought that up.
Yeah, no, I just brought that back because it answered your question. Yeah, the slides are good. So the microphones get plugged into each channel, and the same with like my computer. I have the computer hooked up, and it's plugged into a stereo input. Now when I say stereo, again, that's left and right. This is one channel, one pickup. So we would call this a mono signal. It goes into one channel. The laptop is a stereo signal. It has left and right, so it takes two channels. So basically, how do I want to describe it? Basically, when something's recorded in stereo, you would have to have more than one microphone, because a microphone only records in mono. Does that make sense?
Yes.
So if you want stereo, you want to hear something go from this side of the room to that side of the room, you would have to have two separate microphones to pick that up. Does that kind of make sense? Okay, so that's why you have stereo. And stereo, the main reason for stereo is to create depth and how you perceive the sound. Because something coming straight at you sounds rather boring. But when you hear something different here and something different here, and they're kind of meshing in the middle, it makes it a lot more interesting.
So it's kind of like one, like you, like, one speaker has a way to change this, like, for example, one speaker has a, like this, like this, yeah, and on each edge.
So when you're panning left and right, yeah, and we'll show you that more up here. That's why I have both of these set up. I was only going to do the one, but I wanted you guys to hear the panning. Yes.
So what's the difference between left and right and surround sound?
So surround sound, usually you'll see that in like 5.1 or 7.1. So left and right is exactly that, left and right. 5.1, you're going to have 5 speakers. You're going to have left, right, center, left surround, right surround behind you. And then the 0.1 or 0.2 usually refers to the LFE, which is low frequency effect or subwoofer for short. So you always have a subwoofer down on the floor somewhere with your surround sound, so that's always the 0.1. Sometimes you see 0.2 because they have 2 subwoofers. Probably always wonder what that was, right?
I'm laughing because, yeah, I'm sitting in my VCR just putting speakers in where I want.
There you go.
So
So with that being said, a lot of people will just put up all 5 speakers right here. Completely defeats the surround sound. It's not surround sound unless it's set up
Surrounding you.
surrounding you, exactly. And even so, people will do that wrong because they'll put, okay, the left surround here and the right surround back where you are. And in order to perceive the full surround sound, you have to create the sweet spot, and that's equal distance from every speaker. And I could probably emulate a sweet spot between left and right. Actually, you probably saw me doing that when I was setting this up. I was standing right about here to make sure these speakers were equal loudness. Because if you're standing here and this speaker is a lot louder than this one, then it throws everything off. So you try to find the sweet spot. And if someday you get that set up correctly, you'll find that. You'll sit right in the middle of the room and you're like, oh, that sounds different. that sounds really cool. It plays funny games with your ears. It really does. And it's a lot of fun.
Movie theaters, yeah. Think of that.
Yeah, and don't mean to diss our local theater, but
No.
Not to disown.
Really?
real movie theaters, yes, they will spend lots and lots of money to be able to do that, and they try to do that for every seat. So you don't ever sit in those. But that costs a lot of money, so you're not going to see it in our little theaters, which is unfortunate. But
On the side too.
yeah, on the sides, and they're way too high. Our ears aren't up there. Our ears are down here. So maybe if you ever get to a big city like New York or something, you'll see that it's set up a little bit different.
Or see if you can get out of it. Because I know a really nice view of like coffee chains.
Yep. I guess if you guys want to come up, we'll kind of look at this stuff a little closer now and show you how we can send some of these signals through the board here. And I know I'm talking really fast because I know we're running for time. And with that being said, you guys, if you want to stay a little later because you're interested in something, I'm happy to stay later. Okay, so my handheld mic is plugged into channel 32. So you guys can right over here and you'll see channel 32 right here, okay? And when I speak, you see the SID, signal. Shows that it's receiving signal from my input device, which happens to be this microphone, okay? So now I have to say how much signal is going into this board. So I'm going to hit the select button on this particular board. On the analog board, you don't have a select button because remember there's a whole row of knobs. So those whole row of knobs on the analog board correspond to that channel only. Whereas here, this is our whole row of knobs, and it's good for every single channel on the board. So with that being said, I have to know which channel this is affecting, and I do that by hitting the select button. So with the select button on channel 32, I can come up here where it says preamp. Remember we talked about preamp slightly before? Preamp is exactly what it is. It's a preamplifier. So I'm amplifying this signal before my channel. So I need to make sure this signal is strong enough for this channel to operate correctly. So I'm going to hit this here. You can see right here, this little red dot, it says level. I'm sorry, no, it says local, sorry. 26 dB. Now, audio is measured in, yes, in a voltage, decibel voltage, dB. So I can change that level with this gain on the preamp. So when I speak into this, you're going to see this meter jump, okay? I'm going to turn it way down so you can see it start from the beginning. Hey, hey, hey. Hey, hey, so you see nothing on this meter. I'm going to start to turn this up, and you're going to start seeing signal. See that? And now this signal light also lighting up. Sorry, I'm going to press button to do this. So we want to make sure there's enough signal going into the channel. Okay? Does that look like enough signal, or are you just really not sure what we're looking at? Anybody want more information on that? I mean, we can keep going, or I can answer the questions. So I'm giving that channel signal to my microphone, voltage. It's all electricity. Now again, this is a digital board. So we go from electricity, voltage, to digital, which is basically short for computer. So it changes your voltage to 1 and 0 because it's all digital. It's all what your computers run on. 1 and 0, it's all code. And that's what this digital board operates on. So the sound in this board is not sound, it's a bunch of numbers, a bunch of 1s and 0s.
So if we push that button, will it make it even more?
So by pushing that button no longer allows me to speak into this mic. Pushing that button now takes a signal from the USB. But we won't get into that too much, but that just changes where the signal's coming from. I want it on the microphone, so I'll leave that later on. Exactly, and actually once we get close to be done there, I will show you, I have one set up on the USB that I can show you.
Okay, so we have our signal coming in. We can do a lot of fun things with this, but the most important one that I'm going to show you real quick is what we call EQ, and EQ is short for equalization. And we do that because every room operates a little differently. You guys have probably noticed my sound is reverberating off that wall there. Hear it? It's echoing in here. And we call it reverb. Now reverb is sounds from the original source, which happens to be my voice at this time, and it's going across the room, hitting a hard surface, which in this case is the walls and ceiling and floor, and coming back and hitting your ears. So that's why you hear that echo, called reverb. But if you're hearing it, even though you can't perceive this, if you're hearing it from there, 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 up there, over there, and over there, okay, you're hearing it from every direction. And that's what we call reverb. Okay? So you can, and that's why your voice sounds so good in the shower. Because there's a lot of hard surfaces in the shower, a lot of hard walls and smooth surfaces. And then, I use another term. Well, I guess let's keep it simple for now. Okay, so with that, a lot of frequencies are bouncing around in this room, and everybody's going to sound different. So I'm going to turn this up so you can hear myself now. And you're going to hear a specific sound more than others. And that's the sound that's going to carry the most in this room. So it's a certain frequency.
Charles, you know what frequency? The younger kids, you know what they mean by frequency? Yes, frequency, you guys know?
Have you learned sine waves or anything in school? No, I don't know what grade level it is. Okay, so a frequency is basically everything you hear. Everything you hear is made up of frequencies or different sounds. So you hear the really low part of my voice and the higher part of my voice. So they're all different levels of frequency. Low frequency and high frequency. Okay? So the equalization is going to find those specific frequencies in my voice, and I can basically take a little volume control on any frequency I want and either make it louder or make it softer. So you're hearing that one specific tone in this room called the frequency, and I'm going to find that and turn it down so it doesn't resonate in this room as much. It doesn't bounce around in this room as much.
So when you, just to bring this back to what you guys really know, and I'm not sure about you, I don't know if you've been around, but when they do the sound check, this is what they're doing. This is what they're looking for, is the sounds that revert or are going to cause.
We try to find the not so good sounds and turn them down, and try to find the good sounds and turn them up. Easy to say.
And that's why we're seeing me, I'll yell at the kids and say, you guys got to sing, you got to talk like you're going to do it on stage, sing like you're going to sing on stage, because if you don't...
It's best to use the lines that you're using.
Exactly. And if you don't say it like you're going to do it in the stage, they're not going to find that right tone, and it's going to be different when you get on stage.
Right. Because when I'm acting, I usually sound like this, but when I'm talking to you, I sound like this.
Exactly.
So I don't want to stand up on stage on a mic check and sound like this, because this isn't how I'm going to be during the show.
So then they'll adjust your mic, and then you get on stage, and everything sounds really bad, or it starts to feed bad, you know? And they always look at the sound guy and go, well, what's wrong? And the sound guy's going, are you kidding me? I asked you to say it. So that now you guys know why.
So then, just to keep going on time, we're gonna find a frequency that doesn't sound good in this room, and we're gonna find it by actually turning it up, because we gotta hear it. Once we find it turned up, then we'll turn it down. Does that make sense? Okay. So this is gonna be a little hard because we usually like to do it with two hands. We usually like one hand on the volume of that frequency, and then we usually use the other hand on the frequency, where I can change it. I'm frequency to lower frequency. So that's why I use the other hand. So now I'm only one-handed because I'm holding the mic. So I can do this. It's a brilliant idea. You should be like an audio engineer or something. I'm going to select it, so I make sure I'm looking at that channel, and I'm going to check my gain up here.
What's gain?
Gain is another word for volume.
So even if he was talking into this and it was open, if he had selected the other channel, he would have been still seeing the other channel.
So you watch my voice jump here. If I select this channel, you're no longer going to see it. So I didn't shut this mic off. You have a switch on it. Okay? So that's why it's important on a digital board to make sure you know you're looking at the channel you want to work on by hitting that select button.
Can you look at multiple channels?
You cannot. This screen is for one particular channel at a time, and then all these are for that particular channel you have selected.
Could you have a tablet on your phone?
I could. We didn't get to the tablet, but yes, I absolutely could. Where is it?
Put that down to there.
So when you did the
those
front
knobs are
part,
just like the analog board,
So he adjusts them beforehand, and now all you have to do is do this.
that's what he's gonna do during that sound check, is adjust all these. He's gonna show you.
So I'll be the actor on stage for demonstration purposes, and I'm going to turn up, and you can see the graph go up. Now I have a volume increase at 2.5 kilohertz, so 2,500 kilohertz. Now kilohertz is a measurement of frequency. Again, I don't know how much you want to get into
can I
that.
interrupt real quick?
Yep.
Thank you all for coming to the first Masterclass Monday. I have to go have my dress rehearsal for my final presentation for my master's project. So
Oh, good for you.
I'm going to be in the office. I'm going to be here.
Thanks, Devin.
See you guys.
So you can see that go up, and you can probably hear my voice even though I'm wearing this. So I turn that up at 2.5 kilohertz, and now I'm going to use my other hand to change the frequency. So you watch right here, you'll see the frequency go down, and you'll hear the change in my voice. So now I'm at 654 hertz. I'm going to go lower, lower, and lower, and lower, and now we're down to 33 hertz. And my voice actually doesn't introduce those kinds of frequencies.
You talking regular now?
I've been talking regular the whole time. Yep. Okay, so now you probably heard some funny things going on there, right? What did you hear? We talked about it briefly earlier. Feedback. No, feedback. Feedback. So the feedback, again, is the microphone trying to pick up the sounds on the speaker. So I'm picking up that sound, it's getting re-amplified, and going back to the speakers, and just making that crazy loop, it's all feedback. Okay? So you hear that screeching sound? Oh, that's feedback. You know exactly what it is, and next time you hear that. Okay? Reverb is the sound that you hear after my voice in the room. That's reverb. Okay? Where was I? Here. Okay, so I'm going to sweep that back up until I get to that sound that didn't sound so good. And then what was I going to do with it? Turn it down. Okay. So here we go. I'm going to take it back up. Let's see.
How are you doing?
So the gain is the volume for that specific frequency. We'll look at this one here. You can see 1, 2, 3, 4, 1, 2, 3, 4. This corresponds to the knobs. Okay? And they call this HM. Anybody know what HM is? You have LF, LM, HM. HM. Low frequency, low medium, low middle, or high middle, high frequency. Okay? So, what's the nice thing about this digital board is I basically can take this high middle and use it anyway. Look, I have it way down here in the low. Shouldn't I be using the low one for that? Right, but this digital board allows me to go anywhere. Whereas an analog board, these are going to be set for a specific frequency. I might only be able to go to 1,000 to 3,000 kilohertz with this one. Whereas this digital board allows me to literally go anywhere. So you can go back and forth, all the way up to the high end, all the way down to the low end. Okay? So it doesn't really matter which one I use on this board. Well, for demonstration purposes, we're going to use this one. So here's the gain. You can see it, let volume go up. And let me find that bad frequency somewhere. Oh, there's one. You're ringing. We're going to pass it. We're going to keep going up. Oh, there's another one. Okay? So now I'm going to put my hand on the volume knob, and I'm going to turn it down. So now, that, I can really go down. Look, that's 15 decibels below zero. So that's turning it way down. That's kind of overkill. Because if you take a specific frequency out of somebody's voice, you're going to make them sound not natural. You just want to take that frequency out just enough to make it sound more balanced. Does that make sense?
feedback loop with a combination of both. But if you had put that on me, it would be
It could be a different frequency.
because I have a different voice.
Exactly. But it also plays directly impact with the room.
Okay.
So that specific frequency was for this room with these speakers.
Okay.
I give it a bigger room or a smaller room.
So it's not necessarily your voice is going to be the same every time because if you change rooms, then you're going to want to change.
Yeah, that frequency probably would work okay for your voice, but like you said, my voice is different, so it's going to be slightly different for you. But because of this room, that's more so the frequency that's resonating around this room.
Although if you went in that like sound room, it won't be as much deeper.
So exactly, a soundproof room is not going to have flat, smooth walls, ceiling, and floor. You go into a recording studio, you're going to see a bunch of stuff on the wall, all kinds of bumpy stuff, or these pockets, or foam, or stuff like that. And they're all designed to alleviate or minimize the reverberations, or the sound reflecting off the wall. You don't want to hear that when you're specifically recording, because that sound isn't being picked up in the recording. That's just what your ears are hearing in the room. So you would hang that stuff on the walls to get rid of those extra sounds. They put nice carpet on the floor, okay? And hang things on the ceiling, just to create dead spots, so you don't have sound bouncing
You
around.
guys have been into the high school, those, they call them the clouds. Those are for that reason.
And just off the music suite, they have rehearsal rooms. In the rehearsal room, you walk in, and it's like, wow, it sounds really quiet in here. Big, heavy doors, okay? The sounds from the hallway are like knocked out, so you can't hear them, just from the dense insulation in the walls, okay? And they have panels on the walls as well to keep those sounds from bouncing around.
Why did you pass the one?
What do you mean?
Maybe you're like, let's pass that.
Well, because again, this is the third one, this is the high medium. So I want to find a problem frequency up in that area. I'll use this one to find that lower one. Instead of cross, I'll keep them side by side. So we turn it back up, and I turn it back up here. There's a problem one right there. Now I want to show you something real quick before I turn it down. You have this down called width, and watch what happens to this curve when I turn this width. It's going to make it narrower. So basically, when it's really narrow, it's now affecting only 1.36 kilohertz. When it's a little wider, it's affecting those frequencies that are next to it. So now it's more specific for that particular frequency. Does that make sense? So it's going to be a little bit more touchy now. I'm going to turn it back up so it's a problem frequency, and I'm going to move it around just a little bit. And you can hear that change. Ooh, there's a nice strong one. So we could say that was the most problematic frequency right there. The other ones were a problem, but this one's more of a problem. So now we're going to find the most problematic frequency, and now we'll widen that out to affect those other ones that weren't quite as a problem. Does that make sense? So I'm going to widen it up just a little bit, and then I'm going to turn it down just below the medium line there. See that? Okay? So now I can turn that up, and that is going to probably be just about gone. The only issue with that now is there's another problem frequency that was, I'm trying to find my voice. Sometimes you can find it, sometimes you can't. See? So we're going to find that one. Again, I'm going to make it narrower, and then I'm going to find it. There it is, right there. And I'm going to turn that one down.
So what if you're in the play and you're speaking some lines and then you're singing some others? Does that matter when you do that? I mean, or is it?
It can, yes, it can. But typically, if a really good audio engineer is sitting there, they can catch those types of things and do it instantly.
But you would have the same setup, like you don't say, oh, it's, when they're singing, we're going to use frequency when they're talking. It's pretty much.
No, because that frequency is going to be a problem in this room.
Period.
Yeah, exactly. Yeah.
So how did you know that that was gonna be there?
Because I heard it right there. So then I found the sweet spot, and then turned it down. Is that what you were asking?
No.
What were you asking?
So you said when you brought that down, it was gonna cause something else. Why?
drive your voice, I think.
When you dropped this one out, did that cause the other one, or is that just the one that you had caught earlier?
I knew it was in there earlier, and actually I'm kind of hearing one more in there, and it just, the thing is, you're not going to catch all of them in this position, because again, I'm in front of the speaker. Now if I go step over up here, it's going to be fairly different because you're behind it. Now you just have to go up.
Now I gotta talk into this.
You know, it's
Really wanna-
she's behind the speaker.
I didn't want to talk to this. Woo, yeah, that's, all right, going backwards.
And that's why we always see the speakers at the stage or farther closer to the audience, okay?
That's fine.
We can actually wait at the end of the stage. Because we're out of the light and they're too close to the speakers.
Yeah, exactly.
But you can see it already sounds better, doesn't it?
But there is that ring.
Yep, there is. And we
Ring
can
down
find that.
there. Can you find that ring? Yes, that's the one.
And I can widen out the pictures.
Ring. That's it. That's it. Yeah.
It's okay. So we call that subtractive EQ, meaning that we're finding that specific frequency and we're subtracting it or turning it down. Subtractive EQ is a very effective way to find problem frequency.
So the one thing that caught this is a problem is the speakers are now out in the house, you're on stage. So a lot of times the actors will say, I can't hear the music. Well, that's because it's going through those speakers. It's not in front of you. So that's when we have more speakers on stage.
Speakers on stage, we would refer to them as monitors. So you're monitoring the sound. However, the microphones that she's speaking to don't get piped to those for that feedback reason.
So how do you, sorry, this is probably way jumping way ahead. How do you assign things to different things?
That is jumping way ahead.
Okay, so I'll wait.
And we're running out about 5 minutes here. So
All
I
right.
don't know how long you guys want to stay. I'm welcome to stay as long as you want, but it's up to you guys and that's cool and mine.
Can the next try?
Yeah, absolutely. So,
Do somebody want to come and sing or talk or say something or not?
so
Me?
she's talking at 7:30. Okay. So let me just tell you something real quick. Yes, it's better now that you're over there, but again, this room, our walls, our ceiling, very smooth, very flat. This sound is coming out of these speakers. Where does the sound go after it comes out of those speakers? It hits that wall over there and then does what? Comes back to that microphone. So you're still going to get that feedback loop no matter what. Okay?
Adrian Zoe fix mommy's voice, make
Okay,
it
here,
sound
let me-
beautiful.
I'm going to mess it all
He's
up.
gonna mess my voice up first.
Okay.
What do you want me to say?
So this is the overall volume for her.
I'm in the store and I'm
This
singing.
is the gain is the volume.
Who's skipping? Who's skipping? Who's skipping in the store?
There's the volume, okay? And the frequency, the FREQ is the frequency allows you to move it. See that?
Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Hey! Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. A year or two
So that's the
ago,
band frequency,
I
right?
thought I'd take a ride. But so Miss Mary Bright
Okay.
was seated by my side. The horse was lean and lank. Misfortune was his lot. He got into a snowbank and then he got upset. Oh, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Hey, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh.
Okay?
I'll start over the song
Now,
if you want me
that set,
to.
how do you set another?
You just move over to the side.
You want to say most of it?
Or you get a different microphone.
Come on over. Come on over.
Or you have to-
All right, come on over and we'll tell a joke. And Zoe will fix our voices.
Medium, high medium, high percent. Okay. So we turn it around.
All right, go ahead with your candygram.
See the green, teal, blue, red, so that's the four colors. Green, teal, blue, red. So the gain is the volume, the frequency is how you're changing the sound.
He wants me to sing him a song, and so I'm here now, Daddy. And guess what? I love you, I love you, I love you.
Okay, Al.
That was weird. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Hey, jingle bells, jingle all the way.
Sure doesn't hear it, yeah.
What do you call a teacher who doesn't fart in public?
I don't know.
A private tutor.
Private tutor.
That's excellent.
That was a good one.
You were real close to one there.
I wasn't sure about that one for a second. It's too late. They come over like. You got another one?
Yeah. What's the difference between roast beef and pea soup?
What is that?
You can roast beef, but you can't pea soup.
The Roman walks into the restaurant and he says,
That's right.
I need a table of 5.
That's right.
Does anybody else want to find it? We'll keep going up here all night.
I've got one for you. The blind man walks into the pub with a seeing eye dog, and he takes him by the leash and starts swinging him around above his head. And the bartender says, "When are you doing that, sir?" He goes, "Oh, I'm just having a look around." Seeing eye dog.
Cut those parts out. What do you want to tell us?
Nothing.
How about you do the elf one? You do it really good. All right, go ahead.
I don't know which one you're talking about.
The one where he gives him a candygram.
Candygram?
I want a candygram.
I don't know what a
I'm
candygram is.
here with my dad. Do it, you're good.
No. What kind of beer is best?
What kind of beer?
What kind of berry or bear?
Okay. What kind of beer is best?
Question. What kind of beer is best?
Question. What kind of beer is best?
What?
Answer.
No.
Okay.
Question, what kind of beer is best?
That's a hard one. False. Black bear. Fact. Bears eat beets. Bears beets. Battlestar Galactica.
Now you got to the office. You got a big job.
So we are at our time. I mean, you guys are welcome to stay. Again, I can go further in depth with some other stuff if you want. That's totally up to you. Sarah says yes. Is she
You
happy
can
with
give her
that?
her advanced courses now. Thank you very much.
I don't know anything about the digital board, so this is all.
Yeah, it was a fun experience.
And so, let me answer one question. Why is this here?
Okay, so again, with the digital board, more versatile. This is an iPad, and now I can go anywhere in the venue. So now I can sit where you sit in the seats, and I can hear what you hear. Rather than the back, I hear something completely different.
Okay.
And I can sit down there and change the level. It's all the Wi-Fi. And basically see the same thing.
Can you do that
perfectly for a haunted house because we have something like 12 different zones. Everywhere you go, you hear something different, right? I was walking around like, okay, there's more here and then a little less here. So
Which was way easier than us going, okay, we need a way out higher here.
exactly. Usually Dusty sits up at the board and I say, you guys need to take Vortex down a little bit or take the forest up a little bit. So actually, you look, there's still labels as darkness, fence, I haven't related them. I haven't cleared.
Oh, nice. I was so sad this year. I think that's so much fun.
Vortex, forest.
I admit that I was not a part of it this year. I know a couple days during.
I wanted to, but it just seemed like whatever day it was, I had to set it up or to get something.
We were dealing with the weather. I was not, I admit to it, I don't want to take any credit because they did it.
Yeah, they did awesome, they were awesome. I mean, I really was impressed with what you guys did.
It's like, I couldn't believe.
I'm hoping that next year we do a combination.
Thank
But
you.
maybe we're
I hope you enjoyed it.
It was fun.
Thank you.
They said they were gonna do a donation over there.
Oh, donation, perfect. I will make sure we handle that correctly. Thank you very much.